Hello everyone, welcome back. Today I'm going to start working on a new light sensor, that is TSL2569. Now to gain more knowledge about the sensor and explore it, let's have a visit over the website, that is controleverything.com, and here we have to search for the sensor, that is TSL2569, and here we go. It's, as you can see, it's a 16-bit light-to-digital converter programmable game I2C mini module, and these are some of its features. Please have a look over that, and you can purchase the sensor from here. In this video, I will be interfacing the light sensor TSL2569 with the BeagleBone Black, and the platform will be C language code. And to get there, go to resource tab, and here comes the C code sample. You can download the C code sample as a zip file from here, just like that. And also you can have the code from github.com, and you can download from the repository, that is Control Everything Community. Now let's have a look over the hardware connections we need to set up. Now in the connection of the hardware, first of all we require the BeagleBone Black, which you are able to see on my screen, and this here is an I2C shield. It is available on the website controleverything.com, and the real reason we are using this shield is to make easy connections with other I2C devices. So for that, gently place this I2C shield over the BeagleBone Black, and then now we require our sensor, as I just said, it's TSL2569. Now what do we require is a connecting cable, and gently make the connection among the sensor and the cable, and make sure that the brown wire of the cable should be connected to the ground terminal of the sensor. Then what do we require next is to power up our BeagleBone Black, and there are two things we require for that. First of all, a mini USB cable just like this, and gently insert it over here, this jack right here. And next we have to do that for an adapter which is of 5-volt power supply, and gently insert it over here, power jack. The last part is to provide an internet connection, and there are two mediums. First of all, an Ethernet or a LAN cable, as you can see, and gently insert it over this Ethernet jack. And you can also use a wireless nano USB adapter for the purpose of internet connection. As we are done with all the connections, we require to have a look over the C code. Further, in the interfacing part, in the interfacing section, we have to log in to github.com for the code, and here we go. As you can say, here we have to search for the repository, that is Control Everything Community. Then here we have to search for the sensor, as you can see, it's the sensor TSL2569, and this is the C code. Let's have a look over the instructions first. First of all, we need to set up and connect the BeagleBone Black, and the steps to install it and connect it are provided on the link, that is the beagleboard.org. Then we have to download or git pull the code in BeagleBone Black, and this is the command to compile, and this is to run the C code. Note them down. And then it's a C code, as you observe, it's a .c extension file. In the code, you notice that we have included some of the header files for the functioning, and in the void main function we have created I2C bus, and here comes the checking of that bus, whether it's available or not. Then we have to check for the I2C device having the address of the sensor, that is 0x39. Coming to the writing section part, we are going to send the command, as you can say, first of all we have to select the control register 0x00 or with command register 0x80, and we are going to send command for power on mode, that is 0x03, and here comes the writing section of this part. Then we have to select the timing register 0x01 or with command register 0x80, and we are going to send command for nominal integration time 402 ms, that is 0x02. This is the writing section here. Here comes the delay or sleep of 1 second. After that we have a reading section where we are going to read 4 bytes of the data from the address 0x0c or with command register 0x80, and it's a channel 0 and channel 1 data. And here comes the writing section of this part, as you can see, specifically reading part. Now after that we have the conversion of the data takes place here, which you can see according to the guidelines provided in the datasheet for TSL2569 for the calculation thing. And then we have the output data to be screened, displayed at the very end of our code. It's the full spectrum, infrared, and the visible value, and all the relevant values are in the unit of lux. So we are done with this code. Now let's have a look over the working part. Now coming to the working section, and here first of all we have to copy this entire code as you can see on my screen, and then we have to look over the terminal for the BeagleBone Black, and here we have to create a new file as you can see on my screen with .c extension, and then we have to paste the code we have just copied from GitHub, and then we have to save it. Now for the compilation process, as you can notice on my screen, and this is the command .c, and then you have already seen this in the instructions part, and let's see what we got here. We have the compilation successful, and after that we have to build the code, and this is the command for that. And let's see what we got here. We have the full spectrum, infrared value and the visual value, and when I again run the command we have the values, but it's almost constant. But when I place some object over the sensor, you can see the decrease in the full spectrum, infrared value and the visual values. So this is how the sensor works. But instead, when I bring a light source near to the sensor and run the command, you can see the increase in the full spectrum, infrared and the visible value, and all the values are reflected into the lux, which is the unit of luminance. So this is how the sensor responds. Now let's have a look over the benefits, features and the applications of this sensor. The TSL2569 is highly sensitivity light-to-digital converter that transforms light intensity to a digital signal output capable of direct I2C or SMBus interface. Each device combines one broadband photodiode and one infrared responding photodiode on a single CMOS integrated circuit capable of providing a near-photopic response over an effective 20-bit dynamic range. Now the sensor is ideal in notebook, tablets, PCs, LCD monitors, cell phones and digital cameras. In addition, other applications include street light control, security lighting, sunlight harvesting and many more. The sensor is available on the website controleverything.com, and you can have the code from the resource tab, and after that you can download the code as a zip file. You can also have the code from GitHub repository and its Control Everything community. In the end, I would make to clear that in case if you have any queries, you can have a look over controleverything.com for further queries, and you can post your comments on community page. For articles and blogs which are relevant to this sensor and video, you go on to instactables.com, and to subscribe more video tutorials, go to our YouTube channel. I hope you enjoyed this video and have a good one yourself. Thanks a lot for watching.